So, welcome everyone. Welcome to Pipedrive Meetup. So, first speaker of the day, Nelson. Okay, a bit introduction about Nelson. So, Nelson has been working for Pipedrive for the past 6 years. He started as a senior backend and developer, and since last year, more or less, he has been working as a senior site reliability engineer. Loves tech, microservices, distributed architectures, contributes for Pipedrive engineering blog, and who doesn't know this blog, please go check it out. And before entering Pipedrive, he actually never worked with Node or TypeScript, but now he loves it, obviously, right? So fun fact about Nelson, he was the first engineer being hired in Lisbon, but not sure why. He was actually the second hire in Lisbon. So you need to tell us.
Just time.
Yeah, Jesus. So let's all clap our hands to Nelson.
So thank you for being here today. Let's start. So, simple question. Who knows Pipedrive? And it's not from Pipedrive. Okay, so a few people. Let's introduce a little about Pipedrive. Pipedrive is a software as a service cloud platform. And the main difference between Pipedrive and other platforms is that it was built for salespeople by salespeople. So it basically grabbed all the knowledge and the way of doing things that salespeople do and applied it to its software. So, some facts about Pipedrive. It was founded in 2010 in Estonia by 5 Estonians. Currently, we have 10 offices all around the world, so we are not anymore a small company. And we have 100,000 customers. That by itself says a lot about Pipedrive. We are not the biggest company, but we are not also a small company. We are already a large company. And the customers we serve exist in 170 customers, so we provide a lot of translations to a lot of different languages. About the growth, Pipedrive established an office in 2017 in Lisbon. More or less the same time I joined Pipedrive. I entered in May of 2017, and the office was opened 2 months earlier. Pipedrive gathered $90 million in funding in several rounds of investment, but by now, in 2020, Pipedrive reached the unicorn status. For those that don't know what unicorn status means, it means that it's already valuable in 1 billion. So Pipedrive is worth 1 billion by now. We have 900 employees from different cultures, different languages, engineering, commercial, marketing, support, a large company already. In terms of culture, we have, 50 nationalities, a lot of women working for, has employees, 34 years of average age, 35% of the employees are from engineering, and people basically stay within Pipedrive for 3 years on average. In terms of culture, when I entered Pipedrive, these were the values that were told me that I should accept. And 6 years has passed, and they are still the same values. So be internally driven, reach for greatness, teach and be teachable, put the team first, no excuses, and don't ruin other people's day. About engineering, as I said before, we have 300 engineers. We have a little less than 10 data centers, but we are growing in terms of numbers. And data centers usually serve a region of the globe. 800 services running, that's why we need those 300 engineers. And we do 120 deploys per day. Some are automated, some are not automated, are done by the developers, but on average 120 deploys per day is already a big task for any engineering company. This means around 3,000 deployments, more or less, per month. We have 3,300 VMs, 29,500 CPUs at the time I gathered these numbers, at least, and around 700 terabytes of storage. This basically gives you an idea of the scale of Pipedrive. So the problem. When I entered SRE team last year, there was a problem that I'm going to discuss with you, but that problem led to a solution, and that solution is AutoTuner, a service that was created, built, and designed to solve a problem in terms of resources. So we have a lot of services, we have a lot of regions, different regions have different needs of resources, and that needs generated an idea. So I went to my manager, talked to him about, we have this problem. We discussed the problem, we defined the solution, and we basically started it. This is just an idea, a way to show you that, when we have an idea, it doesn't matter if the idea comes from above or below. I had the idea, talked to my manager, we decided let's do it. And we started AutoTuner. Currently, our continuous delivery stack is based on Jenkins. Jenkins is used currently to do the deployments, do the tests, and basically do the flow between the developer and the deployment. We are currently in the process of migrating it to Argo CD. We also use Helm, has a package manager to store the configurations for Kubernetes. We have, of course, Kubernetes to run it. And GitHub, and we also use a lot of GitHub actions to do a lot of different tasks in the deployment process. So, the problem starts with a simple task, that is, each of our 800 services has a repository, and that repository has its own Helm files. Nothing bigger, not a big problem for now. So we have a folder on each repository. Each folder has values for default configurations, values live for the configurations for live, and values live with the region for configurations for that specific region. So when we want to deploy for a region, imagine Europe or US, we basically get the Helm template. We apply the values for live environment, and we apply, if they exist, for the region. So we basically combine three, in this case with the template, 4 sources of information to get what are we going to deploy. But resources cost money, and if we don't basically manage those resources effectively, it will cost us. And the biggest problem is that because we have all those files in each repository, that means that developers need to go there by hand, change them. So if they need half CPU, they will go there and say, I want half CPU for US or for Europe. And it will get deployed, committed into that repository. Simple, right? But if we consider that we have 800 services times n regions times n variables, it's basically hell to keep that information up to date. So even if we save 0.05 CPU times 29,000 CPUs we have, that means already $51,000 we can save per month. That's a lot of money. And don't forget that one CPU can run several instances of different services. So if we save on a single one, we will save eventually more than that. And also, of course, we can save the hardware and so on, but people eventually even cost more money, because if we have the developers committing and changing things every day, every year, for all the services we have, it's a lot of changes, it's a lot of commits, it's a lot of hours spent. And we are talking about at least CPU, the amount of CPU the service needs, the memory, and eventually the ephemeral storage. That I'm not sure if you know what it is, but it's temporarily storage that it's used for example, backups, to store downloaded files temporarily, and so on. So all of these resources need to be managed by all services in all regions, and it's a pain to basically put this burden on top of developers. So we decided let's do something about it. And the thing is, it's tricky. It's not all about money, but it's the complexity. So if we overbook the resources, well, we can spend more money, the resources are not very adjusted, and the services run on machines. Machines, for example, have 4 CPUs. If you ask for 0.05 CPU and in reality you are using 4 CPUs, well, basically you are running that host out of CPU. And that is a problem, because the resources are not adjusted to the host. So being overloaded or underloaded both have their issues. And that affects CPU, memory, and storage at least. So we have the data in Grafana for all the services. So we got the services, the data from Grafana, and as you can see here, we have the chart from that service. And as you can see, on average, more or less, it spends, a little less than 2 CPUs, and has some spikes that go almost to 3.5 CPUs. So the saga began. Basically, we started to do a service, and the first step was getting the data. But as I showed you, the data is not quite accurate, because if I give 3.5 CPUs, I'm wasting money. Because in reality, on average, a normal day would spend around 1.5 to 2 CPUs. That's enough for this service. So we gather the data from the last 4 weeks of the service running, and we clean the data. So we apply an algorithm for outlier trimming. So everything that goes outside the outlier is considered not being part of the data. So we end up with the same graph, but without the outliers. And that gives me a much approximate idea of the resources needed. So if I give this service 1.5 CPUs, I'm not wasting money. And on top, if I gave that 3.5 CPUs, I would waste half of the CPU. And also, we started to automate the deploys. So basically, we have 800 services. Not all services are currently being auto-tuned. We already have around 100 being deployed. But we get one of those services. The first thing is to download all the repository of that service from GitHub and compare the Helm files with the gathered data from Grafana. So we basically get the repository, we examine the files that are already committed, we identify what is the configuration for every region, and once that is done, we can compare with the data we extracted from Grafana. And there we can say, oh, in Grafana, I have 1.5 CPUs. That is usually how much it's using, but in the configuration file, only 0.5. To be more accurate, some of the services we deploy by default ask only 0.05. So if the developers don't adjust up the CPU, basically they are using more than they request from the start. But once that is done, we basically check the resources that we know we need for each region. And if, for example, the CPU is more or less close to the other regions in terms of CPU, memory, and storage, we group them. So basically, we have 3 levels: the default, the environment configuration, and the region configuration. So all the grouping, if we detect a group, that will go to the environment. So if we have 3 regions with the same defaults, they will go to values, live YAML, and it will be the default for the environment. Any locally configuration will be put on below on the region configuration.
So when you say region, you separate by demographics?
No, per data centers. So we have around 10 data centers worldwide, and each data center has its own needs. So a service, for example, mail, in US will have more load, for example, than in EU. So we need more resources, more CPU, more memory, more storage for that service. Okay? And finally, we update the files. It appears to be simple, but it's not quite simple, because in some cases we need to update, add, or remove configurations from a single file. In the worst case, we need to delete files, add new files if they don't exist, because by default, the only configuration that is needed is the global one. So we have only a values YAML file, and if needed, we extend it for the environment and region. So we check, did we change anything on this repository? In the limit, if everything is equal, we may not need to do any change. If something was changed, we bump the Elm template version file, we commit the branch, and open a pull request. And half of the work is done. So after that is done, we add labels to the PR. I'm not sure how many of you use labels to do deploys, but in Pipedrive, we add a label ready to deploy on a branch, on a PR in this case, and it gets automatically into Jenkins. It gets deployed automatically after a few minutes. So it's basically just adding a label to an approved PR, and it goes all the way to the data centers. And alternatively, if the service, that auto-tuner, the service needs to run some functional tests before, auto-tuner puts the 2 labels, one for ready to deploy and one for running the functional tests. Otherwise, it won't get deployed. And finally, once all this flow is done, we monitor the outcome. Did it deploy successfully? Did it fail? Why? And so on. Once this is in place and all done, for example, if a service fails for some reason, it fails a functional test, a test, whatever, for some reason, AutoTuner will reschedule in 3 days to try to redo it again. Because sometimes some other PR was already ongoing, and there was a conflict, and it was not able to do it, and we need to restart from scratch. So the approval of the PR is done automatically by GitHub Actions, but we instrumented GitHub Actions only to do that between 9 and 5 during the day, basically. So when we start the day, AutoTuner will start fetching services, starts to deploy. GitHub Actions puts the check mark, it's good to go. No other changes than Elm files were done to the repo, and it goes automatically. So one thing that we also did about the adjustments of the resources was not to do very harsh changes. So if we see a service asking for 5 CPUs, we will not give it 5 CPUs. If it asks 1 CPU and we see a trend to 5, we go halfway. What happens basically is this. So on the first deployment, we basically go half the way from here to here. On the third deploy, we'll go another halfway, and over time, it will converge to the real need of the service. We don't do up and down too fast to make sure we don't abuse the resources. Otherwise, we would give 5 CPUs to a service that eventually won't need it. But it also does another effect, that is, if the service goes up and down over time, by doing this, if you notice, we are basically in between the changes. So we are making the resources more stable. So we are not going up and down, we are in between. So we are making the resources behave like a convergence to the real needs and not very harsh changes. So the behavior we have so far is we run it for opted-in services. So in Pipedrive, we have tribes, basically teams of people. They decide which services should be going into AutoTuner. Every 4 weeks, we check, do we need to do another adjustment? We trigger it and deploy it, the flow you saw. And we do at most 3 deploys per hour. Why? Well, if we do 50 deploys per hour, the developers can have lunch because they won't do anything during the morning. That's the problem. So we don't want to abuse the deployment pipeline. So AutoTuner also collects a lot of variables. So it collects information about memory, CPU, storage for those 800 services in all the regions we have, on all data centers. But it also is starting to collect data about sidecars. I'm not sure how many of you know about sidecars, but sidecars basically are containers that run along the other containers. So they are helper containers. And sometimes they do some critical tasks like crypto, like networking and so on. And those sidecars also need the resources adjusted depending on the CPU they use and so on. So we are starting to collect data on the sidecars, and the plan is to adjust the resources also of the sidecars, because some sidecars have more needs than others, and that is important to be fine-tuned so the pair, the container and the sidecar, works good. In terms of auto-scaling, currently we are skipping auto-scaling because auto-scales by definition it adjusts by itself. So if it needs more CPU, it can basically deploy another instance. So that is good. We are skipping it, but AutoTuner will also be part of it in the future in a different way. Instead of adjusting resources by itself, we are basically creating resource templates. So if we define that the container is of type small, imagine small could be 0.5 CPU, AutoTuner will do the math and decide, oh, this uses, if you combine all the CPU used on all instances, this uses 5 CPUs. So basically, when it's time, we can move it eventually to medium or large. So it won't adjust the resource on a fine-grained scale, but on a larger scale. And now let's look what it looks like once we have all the theory in place. So this is a deployment that was generated by AutoTuner. So you can see here that it was merged, so it got deployed. It created the branch. We put the information about what regions we are affecting. We saw that these regions all together went into a group. So basically that means the values live YAML all has the same definition for these regions. And then we have region FRA2 that basically have the specific configuration. You can also notice here that the label auto-tuner and ready to deploy was placed automatically, and the results, the PR, the files, as you can see here, it bumped the Helm file version. It changed the CPU, the memory, and added ephemeral storage because it didn't have any, and created default values live for all the regions except for this one that is only for a specific region. And this is automated. The developers don't need to go here every month or every few weeks to adjust these variables. Here we can see money saved. This is for a small period of time. We didn't save that much, but we saved some money. But here we have the under-provisioning, those services that were not asking for the adequate resources. So we are asking resources here, and we are releasing resources here. So we are saving money, and we are spending money. But overall, the effect is very, very positive. Also, here we have a list by tribes for teams. So we have an average of the distance between the resource needed and resource asked for. And that difference can be above or below. But if we measure that distance on average, all services in AutoTuner are in the top. The top, no, in the bottom. So we are basically making it more adjusted. Overall, as you can see, we have all the tribes with that eventually didn't added the services to AutoTuner, but the discrepancy over time reduces. So when they add the services to AutoTuner, we see a trend going up because we see that the average has gone up with the new service added. And after the deploys, it comes down, and over the weeks, it comes down and down and down, and it's a nice trend. Lessons learned. Don't be aggressive. We should not go ask all the resources or releasing too many resources. Let's give it small improvements over time. This I learned for myself. Don't do coding and testing without proper safeguards, because the problem of using GitHub is eventually the companies don't have two GitHubs. And when we are doing stuff on GitHub, that eventually will cause some impact on live environments. So I caused a small incident. We resolved it. We had two safeguards, one at the beginning and one on the end. So if we are running on test environment, we don't do any deploys to avoid any deployments non-optimal, at least. Questions, comments?
Yeah, thanks for presentation and pretty interesting solutions. So I have a question regarding, so how do you run this AutoTuner? As far as I understand, are you running in the background, or you're doing some manual?
We have a management region. We have all the regions for all the different continents and so on, but we have a specific management region where we can run our internal tooling. And from that point, we run AutoTuner, and we start the deploys and do all the flow. Mm-hmm. Yes. Any more questions?
No, because you were super clear, right? Yeah. Okay, perfect. So next speaker, Ivan.
Hello, everyone. Thanks for coming. This session is like shortened version I delivered in DDD European Conference. Okay, we have 30 minutes, so I squished it a bit. You can feel free to join the Mira board by this QR code if you want to, but it's not necessary. It's mostly for online presentations. So you can just follow the screen and it will be fine. So, some self-introduction. Okay, that's me. I'm from PandaDoc company with engineering office here in Lisbon. We are neighbors of Pipedrive. I don't have a detailed presentation about our company, but it's very close in numbers, so you can imagine something like 800 people, like 35% of engineers. Everything is the same, almost. Okay, but we have much lower number of microservices, and it's also will be part of my speech. And I'd like to avoid mentioning of system thinking here because lack of time. So it's a separate topic. If you're interested, we can discuss later. So, right, so my topic is about strategic DDD, domain-driven design. It's quite from opposite side of things from the first presentation because I'm not be speaking about Kubernetes and SRE and scaling. I will be speaking about how we think about microservices, how we try to make them efficient, not just for the sake of number of microservices, but to make the configuration manageable and stable. So the strategic DDD is a silver bullet. I want you to challenge me to convince I'm wrong. I like everyone to use domain-driven design if you'd like to run a microservices configuration, especially if you're working on dynamic markets and you're in a growth stage. So we need to do experiments, you need to evolve your product, and you run microservices. This kind of complex situation. And if you run microservices without special disciplines, like domain-driven design, you might be in trouble. So I will be convincing you that DDD is all you need for 20 minutes, and then I will give you 10 minutes to challenge me. And for every successful or good attempt to challenge me, I will award you with some swag from DDD Europe conference. So let's see how it goes. Let's start. So skipping the systems stuff, make it a bit more simple for you, because originally it was system thinking with domain-driven design. At first, I like to get into why I think it's important. Like this. Yep. Cool. So I started to speak about environment when we have very dynamic markets, we run in experiments, we evolve. And of course, we can evolve like this. Actually, it's pretty good for any startup, any start. You can just assume you live in a single domain. You have some subject matter expert to cover everything in your product. And you do this or any other feedback cycle to make your product better, market fit and the stuff, right? And it works for some time, but okay, remember we are on a very dynamic environment. At one moment, we want to have multiple subject matter experts who can evolve your product in multiple directions, run parallel experiments, get different feedback, and make more with what you have. And the only reliable way for it is domain-driven design, of course, as I mentioned. And regardless of technical implementation, it might be microservices, very micro, like here, or it might be legacy monoliths, part of the configuration, or it can be a mix of everything. You just need to have different parts of product isolated, one from each other, and have ability, capacity, and practices and tools to evolve all of them in parallel at the same time. And what usually happens when you go without domain-driven design? You can just, of course, run evolution cycle of some part of the product, but the changes in this part of the product can affect other parts of the products, other microservices, or part of monoliths, and it costs a lot, actually. It seems like a small issue. Okay, people work on this element of product, and other people also work, and they affect each other, and list of consequences, yep.
How do you define cognitive load?
Well, for myself personally, it's number of cups of coffee I need to drink before I understand how it works. For other guys, probably it's different units of measure, but sometimes it is converted, this cognitive load stuff, converted into like avoiding change. So, okay, we have very complicated element in the product, and we do everything to avoid contributing to it. So we need new feature, we make it from some side to not touch this complicated part. So it's high cognitive load. It prevents us from doing contribution to this part. So the cognitive load itself is a big topic. I would encourage you to read articles, and we have even, it's very well explained in Team Topologies book, by the way. You can try this one. But it's a big deal, especially if we talk about ownership. I will talk about it a bit later. And what I want to emphasize here, that...
Sorry, when you talk cognitive in terms of human perspective?
Yes.
Human perspective, right?
Yeah.
Okay.
Yeah, correct. And this stuff tends to increase over time. If we do smaller mistake, we start doing avoiding contribution to the cognitive stuff. We do dependencies. We do bad decisions because of legacy decisions, and it's like positive feedback loop. It starts increasing over time. Okay, that's a bad scenario when we do. Let's skip it. And a bit of information over this. Smart managers used to think they can deal with this by applying these cross-functional teams with scaled agile frameworks, but without this ownership of this evolution. It works only for some time, then it's broken because the knowledge is lost, documentation is obsolete, and stuff is not up to date anymore. We need owners who proactively do this cleanup, evolution, technical debt, and so on. So these cross-functional teams cannot solve everything. So we definitely need to work on boundaries. returning to this slides back, I put a microservice. It's actually not a microservice. It's actually subdomains. And, well, why it's here? Because the boundaries needs to be stable in the product. If the boundaries are not stable, you will always have this situation. Boundaries changed, and you come to interference situation. So the only reliable way to have a stable boundaries is to have them put over the functional boundaries. Functional is how system behaves, not how they build, how they constructed, but how they behave. And here, somewhere here, I had a slide about prerequisites. Okay, anyways, moving to this evolution side. So that's important. You have good boundaries, you have stable boundaries, you can evolve things, you will avoid cognitive load and other bad consequences. So let's decide like a real example from PandaDoc, document management domain. So we decide to split one domain into two parts, assign owners, have a vision and strategy for it, put some metrics, and we're fine. But this case is like too idealistic. In reality, I seen teams just create new microservices without assigning this vision and strategy and owner stuff. And this comes into distributed monoliths. So we have boundaries somewhere, we have microservices in another place, and change in one microservice requires updates in another microservice. So we have multiple microservices. We need to change in a transaction. So the only valid reason to split your monoliths into microservices or split your microservice is the explicit owner with vision and strategy, which can motivate you to isolate it. With this isolation, you can evolve, separate subdomains, put some metrics over them, how people use it, how your clients use it, put some monitoring dashboards and infrastructure for them. Tooling for it. Basically, splitting monoliths and splitting microservices is a very costly operation, usually, because you need CI pipeline, you need additional configuration for resources, you need tools and documentation separate. So internal platforms usually built exactly for the purpose of simplifying the stuff like this. I believe Pipedrive also has internal platform. Maybe it has another name, like SRE or Dev Experience, but platforming is the thing which enables this. And, okay, how we can define subdomains and map them to microservices. What I want to say here is that the operation of extracting microservice from monolith or from another microservice is costly. It takes resources, it takes ownership, it takes attention of the team and product managers and quality assurance team, everyone. And you better have the boundaries stable to not put additional technical debt by this decision. Stable boundaries comes from vision and strategy, which can be only done for a product for functional part, for logical architecture, not for structure. If you have 800 microservices, we cannot put strategy for every one of them because we don't understand how we need to evolve each of them, right? We put like logical boundaries. We have like document management domain, we have opportunity management domain, we have CRM subdomain. In our case, it's CRM subdomain. In the Pipedrive case, it's a full-scale domain, right? And we have.
Microservice can be one RT, right?
Sorry.
Microservice can be one
Can be one what?
structure, right? And then you have functions. The microservice is also a function.
Microservice can be everything, starting from a job with autotuner, it might be microservice, but I'm talking about domain microservices, the functional stuff. It might be, we have like 30 subdomains in PandaDoc, and some examples is a document template subdomain. It's how users do templates in these documents. And we have electronic forms subdomain, how people create electronic forms and submit them to create new documents. And we have organization management subdomain, how people manage the organization and assign licenses and enable, disable features. So it's a parts of the product, logical part, describing the behavior. And in this way, each subdomain can contain multiple microservices. For instance, we have live editor subdomain. It has 20 microservices inside, doing different stuff. So the right unit of evolution is subdomain, what I'm talking about, not microservice, because it's 20 microservices doing read replica or analytics over this domain is not element of evolution. Everything together need to involve, and we need clear boundaries for this subdomain to make it efficient. And here I come to continue on this topic of functional boundaries, functional first boundaries, right? So we have a subdomain logical, and we have technical microservices boundaries. And here how we can properly transit from logical definition of microservice to technical definition of microservices. All the slides about this. And depends on the time I have, I can get deeper.
More or less 15 minutes.
15 minutes for everything. So 5 minutes for the stuff and 10 minutes for Q&A, right?
If you feel that you need like a couple of more minutes, I think that's fine.
If people interested in getting deeper into this, of course, I can switch from Q&A to explaining logical and technical architecture mapping. Let's see in 5 minutes. So getting here. So we describe logically the subdomain, which can contain multiple microservices, and it can also be part of the monolith, of course, because if you have monolith, it usually means you have multiple subdomains in a single bigger service. It's logical tech debt, right? And when we talk about decomposing monoliths, we usually talk about let's extract some subdomains into separate bounded context to have it evolve independently from this monolithic stuff. So, well, I didn't ask you in the beginning, are you familiar with domain-driven design and terminology? Sorry, I'm asking it now. Anyone familiar with concepts and terminology, please raise your hand. Oh my God, okay. Okay, so we needed DDD 101 before this. But we describe subdomain in terms of logical elements like this. Some roles has some entities, providing some events and doing some functions. And on level below, we have logical components. And we have scenarios to implement. And example of this for the document domain is here. So we have multiple roles. And you see the signer is highlighted just because it's actually from different subdomain. If we talk about clear DDD, the signing document and managing document might be different subdomains. But we don't have, you remember this, ownership, vision, and strategy separated for evolving the signature part. So we don't want to extract it as a microservice. We keep it in domain monolith, so it's still part of this domain for us. You can see the boundaries, the logical boundaries are very subjective. We can put, like, not ad hoc, but consciously, we can put any entities, roles, and stuff into the subdomain and say, okay, it's our subdomain now. We combined everything in the logical boundaries, we have subdomain, and we work with it as a single unit of evolution. We evolve everything together. All the microservices inside, all the parts of monolith inside. And that's very important. But it's part of separate topic. Why it's important? Because product strategy need to be stable, or you have your boundaries fluid, and you have technical debt arriving, and it may start be complicated. So this logical description of subdomain can be transformed into technical description of like microservice or service or monolith with mapping like this. It's ideal case when you have a green field, you can like produce definitions of data, events, and APIs from this. For a brown field, for legacy system, it can be like here. So you have your logical design, very good and perfect and stable. And you have your legacy implementation like here, part of the monolith with data coupled with other domains, with poorly defined APIs. But you can do technical candidates, more than one. For the same logical model, you have multiple technical implementations with events based on Django signals and then based on Kafka messages. You see, the technical side is separated from logical side. That's another important point of the talk. Domain-driven design helps you to abstract logical design, focus on it, and then produce as many maturity levels, as many candidates, migration steps you need to get to ideal state. Or you will be drawn in complexity of technical description. If you talk about only data schemas, webhooks, and APIs, you can lose the logical part and lost the opportunity to evolve everything based on this vision. This part about enabling platforming and systems syncing, domain stuff, nothing more interesting. So we can come to Q&A part, actually. I squished a lot, I know, and it might not be very clear because it's a bit advanced DDD, and no one here is practicing domain-driven design, but let's try. Hopefully it still has some value. Any questions? Or requests of clarifications. Let's say this way.
Can you summarize for the audience why do we need domain-driven design? Because I don't think many people are confused with that. Why do people need this?
Okay. We need it for because it like it's the way. Okay, better go with this. I understand it's technical meetup, and I come here with strategic DD. Sorry about that. But all the architecture topics is actually how we do better for our organization, right? So ideal product is a monolith written in assembler. It's ideal product. But if you want to manage, evolve it, make it easier for us as organization to do something, we add architecture over it. So this extreme architecture is how we adopt our organization to evolve the product. So, and domain-driven design helps us providing the model, logical model, functional model, not technical model, of setting up the boundaries. And if we keep these boundaries in place and use them when design technical services and do technical decisions, we have more stable boundaries. Less changes over time, less technical debt, less broken communication and bad stuff like I put here. You have manageability, and for different organizations on different stages, it means very different things. Because for dynamic companies, you want speed of change, like time to market. In this case, you probably better stay with monoliths. It's definitely faster to have direct data access. Organize everything, because it provides growth. Growth, because performance of the product is a different topic. When we want to optimize something, we roll back to monoliths. It's faster, always faster. But if you want to evolve something in parallel, speed of what? So you mean performance, delays, slow the request response time, like delays. Yes, that's true. Yes, architecture is very bad. The more architecture, the slower system. Yep, absolutely true. But sometimes we need manageability and speed of change. The scalability of the organization, right? We have 30 developers, we want 300 developers. And if all 300 developers start contributing to stuff, the cognitive load, the famous one, make it broken very soon. So if we have boundaries with ownership, we can scale the organization. Add some more teams to this, add some more teams to that. And they isolated, they can do their experiments, and they have the contracts, APIs, and events. All the cross-domain stuff is governed by, okay, in our case, it's CTO organization. It's might be architecture council or architecture board stuff, which is not bottleneck because number of domains is always less than number of microservices. So it's manageable. So with architecture, we add more manageability and allow the scalability of the organization, the growth, the speed up of change, and more clear evolution, data-driven evolution, and so on. If your organization don't need it, you better not try domain-driven design and microservices. But as I said, the context of Interesting hypothesis, maybe. Never tried this. So yes, if you're not needed the architecture stuff, you better not use it. There's domain-driven design, the microservices. It's if you don't really need to grow, to scale, and evolve, you don't need it. That's the summary. Okay, any more questions? Okay, so we have two asking people. You can choose everything from the table. Some beautiful t-shirts and markers for you. And if something will be like left after you come, everyone else can also pick up the stuff. It's from DDD Europe, this conference entirely about domain-driven design and logical architecture and stuff, which might be not needed. But it's still here and it helps us a lot. Thank you, everyone.
Okay, so thank you, Ivan. So actually, fun fact, this is like the first talk of Ivan in Lisbon, right? So thank you also for that. And whomever is like anime fan, so Ivan is a quite Naruto fan, so just, I don't know. So let's welcome our last speaker. So Jorge. Jorge actually is an ex-Pipedriver, so I know Pipedrive is awesome. So speaking a bit about Jorge, so he studied electrical and computers engineering and started with professional career as an embedded system software developer for IoT-related companies. For the last 6 years, he embraced DevOps engineering, but always playing electronic projects. Free time, scuba diver, love it, never try it, but eventually if I don't die. So thank you, and let's clap, no? Thank you.
Thank you. For those who don't know, Critical TechWorks is a Portuguese company. It was born from a joint venture between Critical Software and BMW Group. And I'm working with them since August last year on this project that I'm going to present to you now, which the main scope is to provide GitHub Action runners for our teams. In terms of agenda, I have like a brief slide saying what I'm going to show. So, first of all, the problem. What was the plan that we decided to follow to solve the problem? What did we found in the marketplace? What was our proposed solution to solve it? And then finally, the results. So, starting with the problem, what we noticed in Citadel was that we were starting to have some scattered infrastructure. We had each team working on different projects, and each one of those projects was being deployed on one specific set of infrastructure that was independent between each other, and that caused some issues in the company, where we start to find that some teams were doing the same thing, but with different strategies. And many of the times we had like just multiplication of efforts and multiplication of costs across the team. So what we had as a plan was to implement a common solution that everyone could use with the same strategy for everyone. Leverage the cloud providers, take advantage of it, make it as easy as possible, as easy as possible to use, and finally to optimize costs. So what did we found on the marketplace? So for GitHub Action runners, we found this action on the GitHub marketplace. It says that it can speed up on-demand self-hosted AWS EC2 runners for GitHub Actions. It sounded interesting. As one good candidate for our problem. But then when we started to look into it a bit more into detail, we noticed that it's structured in 3 main parts. So the first one is an initial job where it spins up new EC2 instances for the runners themselves and outputs a label to use them. The second part is where the actual workflow from the teams is actually used. And then the last one is the job that needs to be added to actually shut down the instance itself. There is some advantage here, like it can also can leverage the advantage of cloud providers, but it also has some disadvantages. So as you can probably notice, on the example, they use Ubuntu latest label from github.com. So it's not fully using the on-demand runners from AWS. It's actually still using some resources from github.com, and it's limited to it. So in our case, it was not possible since some of our teams are using enterprise solutions for GitHub in this case. So we had to find another strategy to solve the problem. So this is our proposed solution. The first part on the top, we opted to use the same strategy as the marketplace solution, just to install an app on GitHub and expect that the developers would only need to specify a label on their workflows, specifying which kind of runner they need. Some teams may need lots of CPU, other teams may need some more memory, large instances or small instances. So this label would be used to actually specify the type and size of the target in this case. And on the bottom, I have here the flow that we planned in to actually spin up these hosts. So first of all, we need to process the GitHub webhooks that we receive from those events that we receive from the GitHub app. We need to spin up EC2 instances with some custom AMIs based on the target that was specified. These custom AMIs would allow us to actually include some custom scripts. This can allow us, for example, to automate the process of registering them on the GitHub itself, or to add some validations, or maybe to actually include the script to shut down the instance as well at the end of the process. So the last two steps are just to run the actual jobs from the teams and then kill the machine, basically, at the end of the process. This is like a really simplified version of our infrastructure at the moment. We collect the events from GitHub, process them on a HTTP API gateway. Then it passes it to a couple of Lambda functions and one SQSQ. And then finally, these are executed in the ad hoc as ad hoc runners, which is basically the EC2 instances that register themselves back on github.com or other GitHub enterprise solution. It supports both cases. From the developer's perspective, this is what it's actually needed. Just to install the app, and on the workflows that they have specified, just change the runs on label to one that is provided by our project. In this case, the cave part, just the name of the project. It can be anything. The most important part is that it specifies the type of the runner. It's a Linux instance of x64 architecture, and it's a general medium target. So it's a general purpose machine with just medium size. We have small, medium, and large, and we have some three types of purposes like general, compute, and memory at this moment. So this is the time that we actually can take, or that we take to spin up those hosts. The process of the Lambda, it's quite quick and negligible. Most of the time it's spent on the EC2 startup process, more than 2 minutes. And then we have, we spend about 20 seconds to register that on GitHub. The GitHub part is not developed by us. The GitHub part is provided by GitHub itself. It's part of their own tooling. But we were not that satisfied with this solution. So because it was taking way too long, like more than 2 minutes to get a runner. What we decided to take a look was for a strategy to have the machines or the hosts already ready to use, and then just assign them to the actual users or teams. So for that, we decided to try out these Amazon EC2 auto-scaling groups. We have created one group for each one of the labels, depending on the size and type. And with that solution, we created a pool of machines that were ready to use. From the architecture point of view, we have to just change the runner's lambda, like the last one, to choose between the AWS auto-scaling group or the ad hoc that I have just showed before. So if there is one available on the pool, it's picked. If there is no host available on the pool, it will create a new one for that request. With these, we actually were able to remove that orange part. So we have just the time for the processing of the event and the time to register them on GitHub. And it represents like a 70% of improvement in average. Now, before jumping into the actual results slide, I have one more thing to show you today. So after discussing a bit more within the team and with our other teams and with AWS engineers, we considered that, or we noticed that it would be possible to scale our project for other kinds of operating systems as well, maybe for other architectures. So with these, we added as well some support for Apple Silicon as well. So the process from the point of view of developers is exactly the same. The only change needed is to actually change the label. Instead of Linux, it's macOS ARM64. And from the infrastructure, we've added another SQSQ and one other Lambda function to process this type of requests. And here, it's explained what it's actually happening inside of each one of those hosts. So due to some licensing limitations from Apple, the process of spinning up and shutting down those machines is much more time-consuming than with Linux. So to shut down a machine on AWS that's basically a Mac Mini, it can take up to 24 hours. So it was not scalable in the way that we were using or applying this logic for Linux. So we had to fall back to virtual machines in this case. Another limitation that we have from Apple in this case is that their own virtualization API only allows us to spin up 2 virtual machines per host at this moment. Those machines are really powerful, but due to these limitations from them, we cannot actually spin more than 2 instances at the moment. The runners Lambda sends this request to a small Python service, which uses this start CLI to actually see if there is a slot available. If there is, it will use one of those slots with a custom AMI from our that was developed by us, like that was configured by us, and it will register automatically on GitHub. If there is no slot available, the runners Lambda will requeue that request once again to the SQSQ, and it will try again after a few minutes. For this solution for the macOS, we have to consider the time for the VM initialization, but it's also quite acceptable, I would say. It takes up to 30 to 40 seconds in total to spin up a virtual machine and register it on GitHub, allowing our teams to actually test the CI process for mobile applications, for example. And finally, this is like our results at the moment. This is a project that just a few months long. So we have currently 16 teams, both using Linux and macOS. We have support for GitHub.com and 2 solutions using GitHub Enterprise Solutions. In terms of numbers, we have an average of about 30 Linux runners in parallel during working hours, but during peak times we already have some hundreds of active runners as well. For the macOS solution, we have currently 8 hosts, giving us 16 VMs with an average of 80% of allocation so far. The areas of work include some services working on backend services for the mobile apps, vehicle data collection, logging, and integration with voice assistants, integrations, mobile applications themselves, and with maps and locations as well. In terms of end users, in this case, our actual clients that uses the apps and the cars, it may affect numbers that are about 10 million users for the mobile apps and about 5 million users for the cars, which includes BMW, Mini, and Rolls-Royce. And with these, I finish the presentation. Just these are just used for GitHub at the moment.
And do you have any other providers for hosts?
We are using AWS for our infrastructure. We spin up EC2 machines from AWS, and they are using, they are registering runners on GitHub at the moment. We don't have yet runners specific to other kinds of solutions like GitHub, like GitLab, for example. We don't support that yet.
Thank you for the very interesting talk. I was curious, the part you showed about the 3 steps, the initial job, workload job, and the shutdown job.
Mm-hmm.
So I'm super curious, how does that look in practice? Is it like one GitHub action runs, adds a label, and then there's nothing running? Like, I'm just curious how it saves those minutes in the middle.
Yeah, so
Yeah.
this is the solution that was that we found on GitHub Marketplace. It's not ours. And what they actually do is that they expect that one initial job and one post job needs to be added on the actual workflows by the developers, and the work and this initial job, it will provide as an output a label that will be used on the middle part. So what we used from this idea was just the concept of using a GitHub app, but instead of expecting developers to change their workflows with another like 2 jobs, we are just expecting them to just change the label itself, and we take care of the rest.
Okay. And so the steps that are run in a GitHub action, are they configured by you for the different machines, or how do they get passed to the instance?
This initial, the process to spin up a new host is handled by our infrastructure, and then in each one of the runners that are created, since we are using custom images, we can actually inject custom scripts, and with that, it allows us to add one pre-job and one post-job automatically with our own logic. That we don't need developers to implement that part. That part is injected by our solution in this case. Okay, then that's all.